Okay, what I'd like to do now is go through a couple of examples, numerical examples using complementary slackness, which is what we talked about in the previous uh, video. And this is what we mean by that. At optimality, we know the slack variable times yi is equal to 0, and the excess variable times xi is equal to 0. Okay, so let's see if we can use this complementary slackness to solve some problems. So the book talks about the Dakota problem, and so for the oops, let me get that back to white again. The Dakota problem is where we're computing some linear program for some desks, and so I'm just going to write down the primal here. We're going to maximize z, and our c here is going to be 60, 30, 20. Dotted with our x, right? And our a is going to be 8, 6, 1, 4, 2, 3 halves, 2, 3 halves, 1 half. And our b is equal to 48, 20, and 8. Okay. Furthermore, well, before we do that, let's talk about the dual. So for the dual, right, we're going to be taking w is equal to c transpose times y, and so that's going to be our 60, 30, 20, right? Wait a minute, is that a 48 or a 45? That is a 48. So I'm going to have 48. Our b transpose y is 28. Okay, dotted with y, such that, well, let's just write our a transpose. And I'm writing it down because later on it's going to be, we're going to actually use this transpose. Okay, 3 has 1 half. Okay, and then our c, right, was equal to 60, 30, 20. Okay, good. Now, suppose that we know our x, our optimal x, is 208, and w, let me say z, is 280. Can we solve the dual? Well, let's see. How are we going to do that? Well, just as a kind of a general rule of thumb here, we've got our x1, x2, x3. We've got our slack variables, s1, s2, s3. And then we've got our excess variables. I'm lining those up with our x's and our solutions to the dual down here. Okay, and I know this one is 208. So automatically, what can we say then using complementary slackness? Well, we know that E1 must be 0 and E3 must be 0. Okay, now I need some information about the S's and the Y's here. And so remember that the slack is going to be B, our slack variables are B minus AX. And so in this case, that's going to be 48, 28 minus, minus this matrix here, 8, 6, 1, 4, 2, 3 halves, 2, 3 halves, 1 half, times our x 208. So if I continue that, let's see, that's going to be 48 minus 16 plus 0 plus 8 is 24. That's going to be 20 minus 8 minus 0. 24 over 12 is 20, so that's going to be 28. That's 8 minus 4, 0, 4, that's another 8. Okay, so we get 24, 0, 0. Okay, so we're going to put those up into this array now. This is 24, 0, 0. Can you read that? 24. Okay, so what does that tell us about our slack variables? Or the solutions to the dual, I should say. The solution to the dual then is going to be 0 something something. Okay, so now what am I left with? I've only got to solve for y1 and or y2 and y3. So, and I also know that e1 and e3 are equal to 0, which means that my first and third equations are going to be equalities, and I know that y1 must be equal to 0. So let's translate that information into a system of equations. So I'm taking this matrix here. Sorry about rotating that down here. I'll go ahead and rewrite that here. Oh, I guess you can see this. This is A. We're taking A transpose, so we're taking this column and this column in my system of equations. 8y1 plus 4y2 plus 2y3 is equal to 60. And y1 plus 3 halves y2 plus 1 half y3 is equal to 20. And then furthermore, I know that my y1 is equal to 0. So that takes this out, and now I just have this system of equations for y2 and y3. So I just have 4y2 plus 2y3 equals 60, and I'm going to multiply this one by 2 to get rid of the fractions. 3y2 plus y3 is equal to 20. And while I'm at it, let's go ahead and simplify this one a little bit. Divide that by 2, and we get 2y2 plus y3 equals 30, and 3y2 plus y3 equals 20. And so maybe let's go ahead and subtract this from that, and we get minus y2 is equal to 10. And I see a boo-boo here. This should actually be 40, so let me change that to 40, and that should be 40, and so that's minus 10. And so y2 is equal to 10, and so then using this equation, I see that y3 is also equal to 10. Very good. So now we've got our solution. This is 10 and 10, and from that we could even get our e2 if we wanted to. Oops. I don't know if you want to get e2. Let's see, where is e2? So we can get that from our 6, 2 and 3 halves equation, right? So we have 6 y1 plus 2y2 plus 3 halves y3 minus e2 is equal to 30. And so let's see, we know that this is 0, 10, 10. So what is that, 20 plus 15 minus e2 equals 30. Looks like e2 is 5. And so that finishes up our solution set, 5. And so here is the full set of solutions. Good. Now the book actually goes through and does a little bit of a economics lesson using the Slack, and you can read that through. We're not going to be talking about the marginal revenue or the marginal cost, but it's worthwhile to read. I know that economics is not a prerequisite for our class, but you might read through that just to see what it's like. Okay, I'm going to do one more, or actually 2 more examples, but we'll have to have another video for that. So we'll do one more video with some more examples before we shut down 6.10.